Okay, circle. Does anybody know the definition of a circle? And then, by the way, this goes in Unit 3, Lesson 1, Investigation 3.
That's R squared.
Okay.
Oh, wait,
This is our last investigation before a formative quiz, which we'll have probably on Tuesday. All right. So Unit 3, Lesson 1, Investigation 3, circles. What is a circle?
Circle.
Something that's what, 360?
Okay. Some of them round, some of them 360. What else?
That's a pi thingy, right?
The pi thingy. Okay, so it uses that ratio pi, right? What else? It's infinite. How many sides does it have?
None.
One.
How many corners?
None.
None. Okay. So we know what a circle looks like, but it's kind of hard to define, right? A circle is a set of infinitely many points. Infinite. A set of infinitely many points. I won't write this. Okay. An infinite number of points okay. It's an infinite number of points that are equal distance. An infinite number of points equal distance from one point. So an infinite number of points that are equal distance from one point. Now circles have special. Alright. Circles have special characteristics, special spots. Okay? So a circle has certain characteristics. One thing is a radius, right? One thing is a center. Okay? In the definition, where does the radius come up? Nope, not the middle. What part of the definition alludes to the radius?
What?
Equal distance, good. This distance part, how far we are from the point, that is the radius of a circle, right? Right?
I'm guessing yes.
And from that one point, what's that one point? Nope. Diameter is twice the radius. What is it? The center. Okay. So a circle is an infinite number of points that are a set radius away from the center. Okay, does that make sense? Now I told you we're going to graph circles. Terrible, terrible drawing. What's that spot? The origin, right? We're also going to call this our center of our circle. Okay? That's going to be our center. Okay. Now this next point. We're going to have this be 10, comma 0. Okay. If 0, 0 is our center, and 10, 0, stop shaking your feet, all right?
I'm not.
Okay. And 10, 0 is on our circle, okay? So 0, 0 is our center, and 10, 0 is on our circle. How far is 10, 0 from our center? How far are these two apart? 10, right? So this is on our circle. That 10 tells us what?
That's the radius?
It's the radius. Good. So if this point right here is on our circle, that means our radius is 10. So we'll write r equals 10. Okay? Our radius is 10. What's another point that will be on the circle? What's another point? If I'm 10 this way, I'm on the circle, right? Okay, so negative 10, 0. Okay, so that's on our circle. Yep, the diameter is twice the radius, which would be 20. Okay, what else is on our circle? Okay, good. 0, negative 10. What else? 0, 10. Because all these points are how many units away from our center? 10. they all have a distance of 10 from the center. Does that make sense? Now, are those the only points on the circle that we can figure out? No. There's an infinite number, aren't there? There's infinitely many points. Okay. So now this green line not a terrible circle. Not my best. Kind of lopsided over here. Okay. That green line represents all the points that are how far from the center? 10. So if I have some point right here, how far is it from the origin? How far is that from the origin? 10. Some point over here, how far? 10. Some point over here, how far? 10. Some point down here, how far? 10. Fun game, huh? Right? Every answer is 10. Every point on the green circle is 10 units away from the center, correct? Okay. Now I told you that what we're going to figure out how to do is how to graph a circle. We know how to graph parallelograms and rectangles and squares and rhombuses and kites. I want to graph a circle. Now I can't just give you vertices because there's no straight lines, right? So we need to make an equation to graph our circle. So let's make an equation. What formula do you think I should use to make my equation to graph the circle? Nope. Nope. It's a formula we've used already this class. Which formula should we use? Nope, that's okay. It's a formula we use this unit. The distance formula, good. Because all these points are how far from the center? They're all 10 from the center, right? So the distance formula, we'll be able to find an infinite number of points that are 10 away from that point, right? So how far is everything from the center again? 10. So I'm going to pick this point right here. We're just going to call this one x comma y. Right? Just some arbitrary x comma y. Now the distance formula tells me we have y2 minus y1 squared plus x2 minus x1 squared, right? That's the distance formula. Okay. Now, which point is going to be my x1 and y1 on this distance calculation here? Which point's going to be x1 and y1? 10, 10's not on here. We're going from here, 0, 0, to here, xy. Which one's going to be x1? 0, 0? Okay. So that means if I'm going to figure out x and y, I'm going to have something like this. y2 minus 0 squared plus x2 minus 0 squared, right? Does that make sense? Okay. Started here, ended there, right? Figure out the distance. How far are they apart? 10. So over here we have 10. Okay. Does that make sense, guys? Yeah. And now we said x and y were just some arbitrary points, didn't we? Okay. So I'm going to plug those in for x2 and y2, so I'm really just going to write like this. Is this okay? Is that okay, guys? I plug these in for x2 and y2. So they can be any xy combination on the green line. Okay. So now I have a system of, or now I don't have a system. Now I have just one equation, right? So last unit, how do I find the solutions to one equation? Okay, we can solve for one of them, right? We can solve for y or solve for x, then use our... Okay. Well, if we solve for y, we can use our calculator, right? Faith, you said pick one and plug it in, right? Okay, or we can pick an x value, plug it in and solve for y, right? Correct? Now we want to make a graph, so should we pick one and plug it in, or should we solve for y? We want to make a graph, so should we pick one and plug it in, or should we solve for y? Solve for y. So let's solve this for y. So First step, how do I get rid of my radical? The square root. Square root is the opposite of what? The opposite of what? Squared. Good. Square root's the opposite of squared, isn't it, guys? So if I square both sides, look at this. 10 squared equals y minus 0 squared plus x minus 0 squared. Now, do I need to keep bringing those zeros along with me?
Yeah.
No? Okay. But I want you to put a little asterisk next to this equation in your notes, though. Okay, because we're going to come back to that equation in a little bit. All right? But I don't need to keep bringing the zeros along with me, do I? So I can write this as 10 squared equals y squared plus x squared, right? Okay. Now I'm running out of space over here, so I'm going to move over where we can see. Okay. So I have 10 squared equals y squared plus x squared, right? So 10 squared equals y squared plus x squared. Now I wanted to solve for which one again? Y. So what do I do next?
Subtract x.
Good. Subtract x from both sides. Not just x, but x squared. So then we have 10 squared minus x squared equals y squared, right? Now how do I get rid of the 2 on the y? Gotta do something radical, don't I? Good. Okay, that's a funny joke because this symbol is called a radical. Okay. So this becomes y. I can't just square root that. But now, ladies and gentlemen, we have an equation that we can put where? In the calculator. Okay, so grab a calculator. Oh, wrong button. Okay. Grab your calculator. Mine's still working. There we go. Want to go to y equals? Oh, that's wrong. And I'm going to type in our equation, right? Which was the square root of 10 minus x squared. So second square root, 10 minus x squared, like that. I just realized I changed my window last hour, so I just put it back to normal. Oh, you're right, it's 10 squared. I'm a bum, sorry. 10 squared, thank you. 10 squared minus x squared. What is 10 squared? 100. So you can put 100 or 10 squared. Thank you, Faith. So now when I hit graph, we have what appears to be half the circle. Why only half? Because when we square root something, we always get positive answers, right? So if I want to have the other half of my circle, I need to do the same equation, but this time I need to do what? Put a negative in front. Okay? Do not put a negative 10 in. So it looks like that. And once we graph that, we get this. Okay. Now the reason why it's oval is because the screen on your calculator, is it a square or is it a rectangle? It's a rectangle. So we go into our window, and this is why mine was changed last hour. We change this to like 12.5, negative 12.5 by 12.5 for x. Then hit graph. Apparently my calculator's having some issues. Okay. Technical difficulties are fun, huh? Alright. I actually just tried to close it on the recording, which I think is kind of funny. There we go. Got it back.
What was the window?
Okay. The window I switched to 12 and a half. Come on. Oh, it's not an hour refresh. Come on. There we go. Negative 12 and a half by 12 and a half. If I look at my graph, I'm getting more circular now. You guys see it now? Okay. That's because my normal window is a rectangle, but this kind of makes it more square. Right? All right, are there any questions about that? Any questions? Kind of a cool equation, huh? I think so too. All right. So let's try an example. Let's say we have a circle. Oh, missing the most important part. Guess won't let me skip this. I asterisk this for a reason. Okay? Because this equation, okay, the equation we have over here that I asterisked, that is the same equation as the one we plugged into our calculator, isn't it? Right? Aren't these equivalent forms because we used algebra to solve? Right? So this equation is also for a circle too, isn't it? But I just can't plug that one in my calculator, can I? No. So I want to take this and turn it into a general form for a circle. So looking at the equation I started in green, what does the 10 represent? What does the 10 that's squared represent? The distance, or the radius, right? So the general form for our equation is going to start with radius squared. Okay? So r squared. And this is kind of big picture. So if you didn't understand what I did here, that's fine. You probably saw a cool picture of a circle. But this next part is kind of the big point, the big picture. All right, Long? Long? There you go. Okay. So r squared. Then this was y. Y was a point on my circle, right? The 0 was what? The 0 comes from where? The origin. We picked the origin to be the what for our circle? Center. Good. So this 0 right here is the y coordinate of the center. So I can write it as y minus, and the y coordinate of the center is actually called k. Okay, so instead of 0, I now have k. Okay. Plus, okay. What came next? After y's came the x. And this 0 right here is the x coordinate of what? The 0 right here is the x coordinate of what?
Center.
The center. And that's called h. So this, r squared equals y minus k squared plus x minus h squared. This is the general form for a circle equation. Right? So if I were to graph a circle, the center would be at h comma k. Okay? And then I hate drawing circles. They always have oval. That'd be the radius. Does that make sense? Does the general form make sense, guys? Yeah? Okay, now let's try an example. Example. We're going to have the center at, we'll go with 2 comma 3. And the radius is going to be 6. So the center will be at 2 comma 3. And the radius will be 6. So try to make the equation. Not this equation. Try to make this one. Okay, plug into that one. We're plugging in those to the general form for the circle equation. Not sleeping helps. What? Oh, I think it will. All right, where does the 6 go?
No, the R.
The R. So we have 6 squared, right? Where does the 2 go?
The Y.
The H or K? The H. Because it's H comma K, right? So 2 is the H, 3 is the K. So 6 squared equals Y minus 3 squared plus X minus 2 squared. And I know you're saying, why are there minus signs? 2 and 3 are positive. It's because this equation comes from what? Comes from the distance formula, right? Comes from the distance formula. Okay. Any questions? Okay. Now I can rewrite that equation like this. I can rewrite it in the same form, and you guys, we're not going through how to do this just yet. So I can rewrite it like this. It's going to be 3 plus the square root of 36, because that's 6 squared, right? Minus x minus 2 squared. Okay? That's in this format. So if you don't believe me that this is going to move our circle, okay, take your calculator out.
Okay.
All right. Plug in 3 plus the square root of 36 minus parenthesis x minus 2 squared. Okay. And that'll be half the circle, right? Right? So then down on y4, you need to plug in negative parenthesis 3 plus the same thing you have up there. Back to the front. Okay. So we can't see the whole thing. And now if I hit graph, it did it again. Come on now. This thing doesn't like me. Did you guys graph it? Did you guys graph it?
Yep.
How'd it look? Did it move the circle? Okay, here it comes, here it comes, here it comes.
That's not.
There it is. Okay. You see now that our circle got moved?
Yeah. Yeah.
Okay. So when we graphed it like this, our circle got moved. Okay. All right. Any questions, guys? Okay. That's where we'll stop today.